Hi everyone, welcome to our RIF Lumino workshop. As probably you all have participated on the last RIF Lumino webinar. What we wanted to make today is have the head of Lumino, who is Alejandro Narancio, and also Marcos Martinez, who is a developer on his team, making us and giving us a showcase throughout all the Lumino network. And the idea of this is to have a practical view, practical vision of how it works. So, I leave the scenario and the stage for you, Ale and Marcos. And thank you all so much for waiting and for joining us on this session that we all know that you all been waiting a lot to see, to listen, and to hear from it. Last comment, this session will be recorded and we will upload it to our YouTube channel, that is youtube.com/rskSmart in a couple of days. So if anyone wants to watch it later or has to leave the webinar, can do so, and there you will find it. I will be backstage sharing with all of you some links. So Ali and Marcos, the stage is all yours. Thank you so much.
Okay. Thank you, Fran. How are you guys? I will start sharing my screen. Hold on. Okay, I'm showing the screen. Okay, so thank you all for coming. As Fran said, my name is Alejandro Narancio. Right now, I'm the RIF architect. I'm Marcos Martinez, who is our RIF Lumino lead developer, in charge of all the development of Lumino. The idea of this workshop is one where we'll be explaining what is Lumino, what are the off-chain payment solutions networks, which is Lumino, which is the integration with another RIF services, how the nodes works more at a high level. And in the second part, the idea is that Marcos will show how to start a node, all the contracts involved, how are the contracts, which is the function of each contract, and how to use the SDKs, how to create like a dApp. If you have a dApp, how to integrate with the SDK in order to interact with the Lumino network. So let's start. First, what is RIF Lumino? RIF Lumino is what we say is our first off-chain payment solution implementation on top of RSK. What is an off-chain payment solution? An off-chain payment solution is basically is a second layer solution. We will try to explain that later. And the idea is you secure funds in the smart contract. The smart contract are the ones that holds all the security of the funds between the different, what we call partners, that are entities, person, or whatever that want to start to make payment between each other. But the real payments happen off-chain, not on the blockchain. So there are peer-to-peer. We will try to see some examples later. And this gave us a lot of some advantages and some disadvantages. So first, why we need an off-chain payment solution, okay? So basically, we say that with blockchain and with cryptocurrencies like Bitcoin, we are trying to create a new financial system, an open financial system, right? And a new financial system that will support people that is probably outside of the traditional financial system. But if we compare the technology right now of, for example, Bitcoin with the traditional financial system, like, for example, big players like Visa or PayPal, we say that, for example, Visa supports around 25,000 transactions per second, PayPal around 200 transactions per second, and actually, they probably are higher right now because these numbers are like for 1 or 2 years, so it probably be more right now, okay? So, and how many transactions per second support Bitcoin? Bitcoin, we say that we support between 7 and 8 transactions per second. You can have peaks of 15, 20, but in general, we can say that in Bitcoin, we can support around 8 transactions per second, okay? So if we want to support this new financial system, we require to have at least the same amount of transactions per second of the traditional one. So let's try to see why Bitcoin cannot support at this moment this kind of amount of transactions per second. What, for example, will require Bitcoin in order to support the same amount of transactions per second that Visa support, the 25,000 transactions per second, okay? First, let's try to explain very, very briefly who limits the number of transactions per second in Bitcoin, okay? The number of transactions per second in Bitcoin is given by the size of the transactions, because the amount of transactions supported is given by the size of the block. Different blockchain has different ways of limit the number of transactions that each block supports. In the case of Bitcoin, it's a matter of size, of bytes. So you have a max limit in size of each block, and all the transactions inside that block cannot get over that size in bytes. For example, in Rootstock and in Ethereum, the limit is not done by the size of the transaction in bytes. It's given by what we call the gas limit in the block. The gas that each transaction pays in the block, the sum of all the gas cannot be over the limit or that the network say the block can have. Okay, so let's try to make some math. What will require to be the size of a block in Bitcoin in order to support the same amount of transactions per second than Visa? Okay, and remember that in Bitcoin, we usually want to have a new block every 10 minutes. So we need that a block to support all the transactions in 10 minutes, around 10 minutes. This doesn't happen always at the same time. Sometimes happen in less than 10 minutes, sometimes happens in more than 10 minutes, but we can say that in average, we want to have a new block in Bitcoin every 10 minutes, okay? So if we say that an average size of a transaction in Bitcoin could be like 300 bytes, okay? We can calculate how much of the data is required to get 25,000 transactions. And it will be around 7 megabytes, okay? So it will be like 7.2 megabytes every second, okay? But since we have blocks of 10 minutes, we can calculate that the size of the block required to support this amount of transactions per second will be around more than 4 gigabytes, okay? So basically what this means is that all the users, all the nodes, all the full nodes will have to download more than 4 gigabytes every 10 minutes. And there is something that we always follow in Bitcoin, that you know, in Bitcoin you have two different participants, two different type of participants. Ones are the miners. The miners are the ones who mine the blocks, generate new blocks, and they had to invest a lot in hardware to be competitive because they get an incentives. They get the rewards of the new Bitcoin generated and all the fees. But there is another participant that is very important in the Bitcoin network, which are the full nodes. The full nodes are nodes that have a full copy of the blockchain, and they validate that all the new blocks follow all the consensus rules of the network, okay? And we want that anyone with a normal machine or with a normal machine of the time will be able to run a full node, because we want to as many full nodes as we can, and the full nodes are not incentivized. You don't get any pay for running a full node. You just do it to make the network stronger, or if you want to interact with the network, you need a full node in general, okay? So what happens if you download every 10 minutes more than 4 gigabytes? You will have an increase in a monthly increase of your database of more than 18 terabytes. And this will be very, very, very hard to support it or to be getted by normal people. Okay, this will require a lot of investment in internet, in bandwidth, and in storage for sure. Okay, so this will not scale. Okay, so which is the solution? The solution is what we mentioned, is we have the blockchain and create on top of the blockchain what we call a second layer solution, like an off-chain payment solution like Lumino. There are different kind of solutions to make the same thing. One are payment channels like Lumino. There are ones that called, for example, commit change, etc., etc. Right now we were talking about payment channels, so for this kind of solution. Okay. So which are the main advantages of the off-chain payment solutions? There are basically 3 and maybe 4. The one is some kind of arguable, but the first one is low transaction fees. Okay. Again, we want to create or to support a new financial system, right? And in this new financial system, we had to support all the use cases of the traditional financial system. This is, for example, my microtransactions. If I go to a grocery store and I want to buy a cookie, and the cookie costs 10 cents of dollar, and I had to pay $1 for the transaction fee, I will not use this payment method because it costs me more to use it than the cost of the item I want to buy. So the transaction fees are very important, okay? In another use case, maybe it's not that important. If I want to send money to Europe, I want to send $1 million to Europe, and they charge me $1 of fees, I don't have any issue to pay. But if I want to buy some item and I had to pay more fees than the cost of the item, that will be probably an issue, okay? The other problem are the confirmation times, okay? We say that, for example, in Bitcoin, in order to get sure that your transaction will not be reverted, or will not be reverted, you had to wait to be very sure around 30 minutes. You had to wait around 3-4 confirmation at least. Okay. In the case of Ethereum or RSK, you had to wait around, I don't know, 4 minutes, 5 minutes, depends. Okay. In these kind of solutions, the idea is you have almost instant payments in the time of milliseconds or seconds. Okay. It's very, sorry, it's very similar to what you get when you go to buy something with your debit card. You have to wait a few seconds. The idea is to have the same thing. Okay. The other one is this can be something an advantage or could be a disadvantage. Is privacy. As we will see later when we explain the protocol, there are some things that are stored in the blockchain and keeps public to the rest of the world. But there are the particular, each payment, it gets tracked peer-to-peer, and it's not tracked in the blockchain. So it's not public. You cannot know exactly which payments are made. Okay, that's increase the privacy. Maybe it's a good thing. Maybe it's a bad thing. Depends of the view. And the fourth one is the number of transactions per second. In this kind of network, the idea is that you can support in the order of thousands of transactions per second. And besides what happened, for example, in Bitcoin or in Ethereum and any blockchain solution, where if you add more nodes to the network, actually the transaction per second doesn't increase, it doesn't matter. In this kind of network, if you have more channels, if you have more nodes, the transaction per second rate is increased with that, okay? Perfect. So that until now, this was general to all the off-chain payment solutions, okay? Right now, we will focus on Lumino. The idea is first start to explain some attributes after the protocol and some draft, very raw abstract architecture or very general architecture. And after that, we'll continue with the demo. Okay, I will try to go faster to don't take too long. What is Lumino? We already mentioned is the first RIF off-chain payment solution. The idea is you can create payment channels for any ERC20 token deployed on RScape. Okay. The first release was made in May in 2019 in Consensus Conference. And we released the Light Client, the first version of the Light Client that Marcos will show in December of 2019 in La VidConf conference. And there are all other similar platforms that made similar things for other blockchains. The most famous or the most known is Lightning Network, which is the off-chain payment solution for Bitcoin. The other one is Raiden, which is for Ethereum. Lumino is actually a fork of Raiden, and both teams, we are trying to work together in order to collaborate between each other in the advances we made each for our side. Which are the difference and the difference with and the similitudes with Lightning Network? Okay, the first one, in Lumino we support any ERC20 token. In Lightning, of course, you can just pay with Bitcoin. It doesn't have sense to have token because they don't exist in that platform. The invoicing system is compatible. We are always trying to be very near and very compatible with the Bitcoin community or Bitcoin ecosystem. And the Lightning Network created a standard for an invoicing system, which is basically a standard to request a payment. You can request a payment to someone and say, okay, you have to pay me this token, this amount, the invoice expires in this date, etc., etc., etc. What we did, we added an invoicing system in Lumino following that standard to be very compatible with Lightning Network. Our Lumino, of course, is integrated with the RIF suite, which includes at this moment, the integration with the naming system, with RNS. And this is very important for me, possibility to implement complex business rules. For the nature of Bitcoin and of an RSK, since we have smart contracts in a Turing complete smart contract platform, our smart contracts, the ones that secure the funds, can have business logic more complex than the ones that you can write on Bitcoin. That's something very important for me. So a very draft or very general architecture diagram of a Lumino node. This is a node. Basically, Marcos will show how to set up the node. Basically, it's a Python. It's writing in Python. A normal node manages a private key. You have to supply a key store in order to make the signature of all the different messages, and expose an API, a REST API, where you can manage the node, and also a website where you can do mostly everything that you do with the API from the web. Okay, and this is connected with different nodes in the network. Each node is the same, has the same architecture, and you have to start to create payment channels between the nodes. Okay, so you can create different kind of topologies of payment channels. The different colors here represent different tokens. So in this case, it's something that we probably show in the demo. For example, here you have a payment channel between A and B. You have two payment channels in two different tokens, in the red and the yellow. Okay, but for example, for the token, the red token, you don't have a direct payment channel between A and C. Okay, so for that reason, you cannot make a direct payment. But what you can do is what we call a mediated transfer or a routing payment, that basically you can make a payment to C passing through B. So basically what will happen, A will pay to B and B will pay to C. It's something that, so that's what that means, that you actually don't need a direct payment channel with the one that you want to make the payment. You just need a route with enough funds, enough deposit, enough tokens in order to make the payments. Of course, if you want to make, if A want to make payments very often with C, it would probably be better to create a payment channel directly. Okay, but if it's something that you want to make, a one-time payment, it probably will not be very useful because he will require to make a lot of on-chain transactions, and it will require some cost to A in order to open the channel. We will see this later. Okay. So how does this work? How does it work? All the process. How I'm on time. Okay. Okay. So let's try to explain how all the components interact and how all the message, the involved message are interchanged between the different parties. Okay. So in the left, we have like the RSK blockchain. We have the Lumino smart contract. Actually, there are multiple smart contracts. Marcos will explain this, but we will start with this. We will represent this like all the Lumino contracts. Okay. So imagine we have P1 and partner 1 and P2 partner 2 are two accounts in RSK with some funds in some tokens. For example, partner 1 has 7 tokens of RIF and partner 2 has 3 tokens, 3 RIF tokens. Okay. So basically, the partner 1s will download the node of Lumino. Partner 2 it will start the node, as Marcos will show very soon. And these two circles represent the nodes of Lumino. Right now, they don't have any connection between each other. Okay. And on the left, there is like a timeline where I will try to explain all the messages that are interchanged between all the different parties. So in order to imagine that partner 1 wants to make payments to partner 2, the first thing that he has to do is create a payment channel. Okay, he will make an on-chain transaction, I will say, to the Lumino contract, and will say, okay, I want to create a payment channel with a partner 2 in this particular token. In this case, my token. Okay, no RIF token, my token. Okay, so this will create a new structure in the Lumino contract. Okay, and he will put, okay, partner 1 has 0 token of my token, and partner 2 has 0 token of my token. Okay, in this new channel, in the channel 1. Okay, the next thing partner 1 and partner 2 has to do is make deposits of token in their side of the token, of the channel, of the payment channel. If you see, there is a new line, a new blue line between the circles P1 and P2, and has a 0 in each side of the channel. Okay, so the next thing is to make deposits. First thing, an on-chain call, partner 1 make a deposit of 10 tokens into the contract of Lumino. So he increased in the structure of the contract, he increased the balance and is increased in this side of the channel. And partner 2 do the same thing, but he make a deposit of 3 tokens. It's not mandatory that both sides has balance. It's not mandatory that both make the deposit. But until now, everyone knows that a channel between P1 and P2 was created, and that P1 make a deposit of 10 tokens and P2 make a deposit of 3 tokens. Okay? This is on chain, this everyone's know. But from this moment and until the end, this will happen off chain. It will not be notified in the blockchain, it will not be a transaction in the blockchain. So imagine a partner 1 wants to make a payment to partner 2. The first thing that he has to do is create a locked transfer. Okay? A locked transfer is a special message, a special transaction where basically partner 1 calculate a secret, a random, make a hash, make an image of that random, of that secret, okay? Create a transaction and unlock 7 tokens in this case, okay? So basically, this locked transfer has 1 or 2 outputs. One output is that someone can go and redeem the transaction with a secret, okay? And the other one is it could make a timeout after some number of time, okay? So when the partner 2 receive this locked transfer, say, okay, partner 1 wants to make a payment to me of 7 tokens. He sent me a locked transfer, but I need the secret in order to get this payment in case we had to go on chain. So he has a secret request. Basically, partner 2 asks to the partner 1, hey, give me the secret to unlock this transfer. Okay? The next message will be a reveal secret. There are a lot of more messages in the middle, which we removed because there are more ACKs, like acknowledge that I received this message, I processed the message, they are not that important. These are the principles. So partner 1 basically reveals or sends the secret to the partner 2. And after that, may send also what we call a balance proof. Okay, a balance proof is like a signed check in the real world that say is signed by in this case by the partner 1 that says to the partner 2, okay, I really made a payment of 7 tokens. Okay, with this balance proof, partner 2 can go to the smart contract and validate that he really received a payment for partner 1. Okay, it's like a signed check by P1. If after all this, partner 1 say to the smart contract, I didn't pay any token to partner 2. Partner 2 can go to the smart contract, present this balance proof, and the smart contract will validate that was signed by partner 1. And even if partner 1 say, okay, I didn't make any payments, since partner 2 has this signed check, he will send the tokens anyway to partner 2. Okay, so and the last phase is, for example, partner 2 say, okay, I don't want to make any more payments with partner 1. I want to close the payment channel. Okay, this requires another on-chain transaction. Okay, another on-chain transaction where the partner 2 will say, okay, I want to close this payment channel. These are the balance proof that I have, and will be a time window where the partner 1 could present their own balance proof. Okay, there is a period that is you establish the how many tokens for when you deploy a new token. You can say right now we use 500 blocks. Okay, so what this means, partner 2 in this case want to close the channel with partner 1. Okay, so he present all the balance proof that he has, but the channel is not completely closed, it's not settled. He waits 500 blocks, and partner 1 has that window to present new balance proof. So in case partner 2 want to steal some tokens from him, some payments, he can go and present the balance proof, and the smart contract will always take the most present ones. Okay, another mention is that anyone can close the channel. Partner 1 can close the channel, partner 2 can close the channel, anyone can open the channel. Partner 1 can open the channel, and partner 2 can open the channel. This is not a mandatory order. Okay, and of course all the green arrows are the off-chain messages. So this can happen one time or 1 million times. Okay, and this is never recorded on the blockchain. This never is peer-to-peer. The only one that has the records that this happened are partner 1 and partner 2. Okay, so this is how the flow works. Of course, after the settlement is done, you can see that right now in the blockchain, the partner 1 has 3 tokens. He has 10, now has 7 less, and partner 2 right now has 12 tokens because the balances were updated. Okay, this is how the protocol or the process work in a very high level. And the last thing I want to explain is the concept of the light client. We created the light client, as we say, in December. We made the first release. And why we need a light client? Okay, we mentioned that this was the architecture of a Lumino node in the Lumino network. But the problem is this kind of component, this kind of architecture was left outside a lot of clients that we want to support, like for example, dApps or mobile applications or any client that could not run a Python code 24/7. Okay, so we're required to create something that something that ran in a secure way, for example, in a mobile phone. So for us, was not an option that someone else manage your private key. So we create what we call a hub. A hub is like a Lumino node, but it's keyless. It doesn't manage any key store, okay? But he knows how to deal with the protocol that we explained before, okay? And we have different clients that connect to the hub and create channels and make payment through the hub, okay? There are some securities in order to prevent that the hub can steal some token, etc., etc., etc. Okay, this is the basic architecture. And some features of the light client is allows dApps and wallets to connect to the Lumino network. It's implemented right now in JavaScript with support for React Native. The idea is to make forks in Swift and Java in the future. The private key is always managed in the client side. It never left the client side, okay? And this is a very abstract or very high-level architecture. You have the Lumino Hub, is the company we just explained. We have the wallet and the dApp or the client, okay? We have the SDK, which is this JavaScript component we just mentioned, and we have a long pooling with the hub. And basically, the SDK starts to ask to the hub if he has some messages for him. And if the hub has some messages, it will send to the SDK. The SDK will process. If he has to sign the message, we'll sign the message and send it back to the hub to continue with the process. So the ones that make always the signature of the messages with the signing of the messages with the private key are in the client, never in our servers or in the Lumino Hub servers. Okay, so there are two more components, very important components in the SDK. One is the signer. The signer is a component that uses the SDK, that basically the SDK will send a raw transaction, and he only requires the transaction to come signed with the private key of the user. We provide a normal or a basic implementation using Web3.js or Ether.js, I don't remember. But anyone can implement their own version. Basically, it's a handler that you can implement in your own way. And the second one is the storage. The SDK manage like a state machine of the different states that are in the different channels. So with that state, he can validate that one of the things is that the Lumino Hub, the messages that he sent make sense based on the state of the different channels, okay? For the storage, it's also a handler. We provide a basic implementation which uses local storage, but basically he receives a JSON that has to be stored, and he wants to retrieve the JSON to iterate the state from zero when you start up the application. And I think it's done. Right now I pass the control to Marcos.
Okay, thank you, Ale. Let me share my screen. Okay, so we listened to Ale about all the theoretical aspects of the Lumino solution, but now I'm going to show you a demo and an overview of Lumino, going more in depth into the solution and the technical aspects. So what are we going to do? We are going to set up a Lumino network with some nodes running over the RSK reg test environment. We are going to make some payment from that node, mediated payments and P2P payments. And finally, we are going to show how to integrate the Lumino Light client into a web application and start making payment from our browser. Why are we going to do this, or which are the main objectives of this workshop? For the people that follow the project, you will know that there were several instances where Lumino was presented in a theoretical way, but now we want to give the developers a closer view of the project and more information about the different components, so you can start contributing or just make some proof of concept using Lumino. Since we are quite a few, and it's the first workshop, we are going to go quickly, and we have an environment already prepared But we would like that, since the workshop will be recorded and slides will be available, that you can take some time later in order to set up an environment and perform some tests. That will be really nice for us. And how are we going to do this? Well, we need to deploy first the set of smart contracts of Lumino. These smart contracts define the rules of the network that must be followed by each node. And we are going to give a brief explanation of those contracts. Then, after the network is created on chain, we can build a node from the source code and run it. And we are also going to start a hub node in order to allow remote connection from a light client. We have an example DApp that is already integrated with the light client, so we are going to use it. So, okay, let's start with the Lumino contracts. Lumino actually it uses 4 contracts: the token network registry, the secret registry, and the endpoint registry that is currently deprecated, so we are not going to talk about it. What is the token network, the first contract and the most important of the Lumino contract suite? In order to start using a RSC20 token into Lumino, the token first must be registered on the network. And when the token is registered on the Lumino network, token network instance is created. Then the instance of that token network will be in charge of the management of all the channels life cycles. That means the channel creation, the deposits, the closing of a channel, and the settlement of the channel. So this contract also provides information, public information about the channels of the token. And basically, this contract is super important because it's in charge of any on-chain operation that Lumino Node or a Lumino Light client does. Then we have the token network registry. This contract is deployed once per Lumino network. For example, if we go right now to the Lumino mainnet, you will see that there is only one token network registry. And the principal responsibility of this contract is to allow the users to register new RSC20 tokens into the Lumino network, and allows through contract events to the dApps and the users to notice when a token is registered. So, as we said before, registering a new token implies the creation of a token network. So we can say that this contract acts like a factory of token networks, creating the token network instances and deploying it on RSK for each registered token. So, for example, if we register the Lumino token and then we register the RIF token, we will have 2 different token network registered, and this token network registry will be in charge of creating the instances. And finally, we have the secret registry. This contract is also deployed once per Lumino network, and the idea with it is to allow Lumino nodes to store the secrets of the payments for the situation when a node wants to send a payment to another, to a receiver of a mediator, and that receiver of mediator is offline, and it can receive the secret. It cannot complete the protocol. So when a node registers on chain the secret, the rest of the nodes that are implied on the payment can listen to the secret reveal event, and they can unlock the payment. So that's pretty much the 3 involved contracts. Now we are going to go more in depth in order to know the basic structure of the contracts. Here are the principal contract variables of token network. And here there is a QR code that you can scan, and this will send you to the Lumino contracts repository, and you can see the full Solidity code there if you want. But right now, I'm going to go through the principal variables and functions of the contract. So first of all, the token network has a reference of the token that was registered, and why this is necessary in order to work. So this is necessary because in order to make a deposit, the token network contract must know the balance on tokens of the node that wants to deposit. So for example, if an user wants to deposit 10 RIF tokens and it only have 3 tokens, the transactions of deposit should be rejected by the token network. And also for the successful transactions, the deposit tokens are locked on chain, and they are transferred for the user address, the Lumino node address, to the token network address. So the user must first approve the token network contract to receive the tokens, and then the token network will execute the transfer from method of the RC20 token to move the tokens from the user to the contract, the token network contract address. So basically, the token network works as a custodial of the on-chain deposits for Lumino. Then we have the channel counter, that is unsigned int and represents basically the identifiers of the channels, of the opened channels. Then we have a mapping that links a channel identifier with the channel struct that has the participant addresses and the state of the channel. That means if the channel is opened, is closed, or has been settled. Then we have the unlock identifier to unlock data. That is an important variable. This basically is used to store the unclaimed locked transfers. This is important because if a node executes a settlement and provides an outdated balance proof, the settlement function will store the data that can be unlocked later on this mapping. And finally, we have the limits of the network, a channel deposit limit, that is the maximum deposit per participant on each channel, and the total deposit for all the tokens. So these two variables is like a mechanism to limit the users the amount of money that we want to put in the network. For example, if we are I don't know, testing Lumino integration in one mobile application that we're working on, maybe we want to start with really low deposits per channel in order to test it. That's pretty much the most important variables of token network. Then we have the principal functions of the contract. Open channels, open a channel between the participant 1 and participant 2. As Ale says, both addresses can invoke this function. And then we receive also the settlement timeout. That is the quantity of locks of the settlement window. During the settlement window, a node can submit the balance proof signed by a partner. So a good settlement timeout will be like 500 blocks or similar, because is approximately 2 hours and a half in mainnet on our case. So that's a good time in order to a node that is offline to go back online. Then we have the set total deposit, also can be called by any side of the channel. Receives the channel identifier, the participant address, that is the address that is making the deposit, the amount in tokens to deposit on the channel, and the partner. If the total deposit execution is okay, the amount expressed on total deposit will be charged into the token network contract address and decreased from the address of the user. So finally, we have the close channel, and that is a function that can be called by one of the participants, providing the channel identifier. The partner address is also required, exactly as the deposit. But this function also receives a balance hash. And that balance hash is really important because that balance hash is the hash of these three values: the transferred amount, the locked amount, and the locked root. The transferred amount is the amount of tokens that has been already transferred. That means the successful payments. The locked amount is the pending transfers, and the locked root is the root of a Merkle tree that is the union of all the payments. Basically, all the leaves of this Merkle tree are the hashes of each payment, and the locked root is received on the closed channel. So this is like a user closes a channel, and on the balance hash, it sends basically the balance proof, the first balance proof to close the channel. So then we have the update on closing balance proof. As we said, when a partner closes a channel, it provides the first balance proof that contains the payment that he has received from a partner. But when the partner detects that, it must invoke this function in order to submit the information of the payment received to the contract. So the first participant closes the channel and provides their vision of the balance proof, and then when the partner notices about that, it has the possibility to update a non-closing balance proof that is newer. So this method can be invoked many times as we want, but only during the settlement window. And the idea is just providing the latest balance proof received from a node. Finally, after the settlement window is finished, a node can invoke the settle channel function and provides the local state of the latest balance proof for each side of the channel. So the contract will first validate if the information received is coherent with the balance proof submitted previously, and it will split the local balances into each side of the channel, invoking the RC20 token transfer from function for each participant. And after that, the channel is settled and removed. But what happens if one of the participants didn't behave correctly and sends incorrect or outdated information on the settlement invocation? That's when it comes the opportunity to invoke the unlock function. Because the smart contract guarantees that the pending transfer will be locked into the token network. Any participant of the channel can invoke the unlock function, providing all the Merkle tree leaves that represent all the payments sent and received. So the contract will compute the locked root, the root of the Merkle tree. And if the leaves provided matches with the data stored on the smart contract, it will release those funds. So the unlock function is a way to recover your funds if a participant sends wrong information on the settlement, basically. Okay, so that's pretty much the token network. And then we have the token network registry. Let's see how the token networks are created by this factory contract. The registry contract, basically, as we said, is the user it allows the user to register tokens into the Lumino network. And for doing that, it provides this function, the create RC20 token network, that receives the token address and the limits of that network, and creates a new instance of token network. After this contract function executes, a new token network event is dispatched, so any DApp or user can know if a new token is registered on Lumino. And finally, we have the secret registry. This contract stores the secrets on a mapping and provides a function to register the secret, and another one to get the registered secret via block. So this is relevant because, as we said, for when a node is offline, and we need to know a secret in order to complete a payment, the nodes can register the secrets on chain and listen to that registrations in order to receive the secret and unlock the payments. Something that is important too is that registering a secret implies an on-chain transaction, and that consumes gas and involves expenses on the sender of the transaction. So each Lumino node can decide if it wants to register the secret or not. And that depends on the amount of chain transaction that he made. For example, for small payments, maybe it doesn't make sense to pay the transaction fees. But for an amount of tokens that represents more value than the transaction fees, it will be a good idea to register the secret and complete the payment. So, okay, after the explanation of the contracts, let's start using Lumino. As we said, I have already deployed the contracts on a development network, but I'm just going to give you a small overview of the documentation in order you can test the contracts if you want. So the repo is on the RSK Smart Lumino contracts. And basically, in order to deploy the smart contracts, you will need an RSK account with RIF BTC balance, the Python, pip, and Virtual-M. And in order to install the contracts, you just need to create a new environment, activate it, and execute the installation. After that, you have different scripts. One for the deploy of the token network registry, secret registry, endpoint registry, and then you have another script to register the tokens. So the first script that we need to invoke is the Lumino contracts deploy, Lumino, that receives these parameters, the private key, that is the path of the RSK account private key, a key store file that has some funds in order to invoke the transaction. The version of the contracts, that the current one is the 12th. The maximum amount of tokens, this is a limit for the registry. For example, if we set it on 10, we can register only 10 tokens. And RPC provider, that's basically the URL of the RSK node. So after executing the script, you will receive the addresses for the token network registry, the secret registry, and the endpoint registry. These addresses are important because the register script will use it. And also, when you start a Lumino node, you need to show the node which are the addresses of the contracts of the Lumino network. So after we have this, we can go directly to the register a new RC20 token into the Lumino network. And this script uses the token network registry of the previous step in order to register the token, and the address of the RC20 token that we want to register. And as we mentioned before, it also received the channel participant deposit limit, the deposit per channel, and the full token network deposit limit. So, okay, let me go back. So after the contract, after we deploy the contracts, running Lumino is pretty simple. On the README of the Lumino node that is written on Python, we have the instructions to install it on Ubuntu or on Mac OS. The instructions are very similar for each system, but Basically, in order to run a Lumino node, you need a RSK node that is synchronized with mainnet or testnet, or a write-test RSK node, an RSK account with RBTC balance, because you will need it in order to open channels and making deposits. The installation itself is really similar to the contracts. You basically need virtualenv, pip, and basically invoking the pip install with the requirements. And basically, to start the Lumino node after the installation succeeds, Lumino provides a command line interface, and it receives some parameters. Lumino receives the key store path, that is the path of the key store file of the address of the Lumino node, the network ID, if you are going to use it on mainnet or testnet or write-test, the endpoint for RSK, the contract's addresses, what will be your REST API of Lumino URL. If you have a RNS domain associated with the address of the Lumino node, you can put it here. And then we have this flag, discoverable, that if it's present, then your node will be registered on the Lumino Explorer. That is an application that shows all the channels of Lumino. And finally, you have the hub mode, that is a Boolean flag. And if you enable it, your node will run as a hub. And if you're not putting the flag, the node will be work as a full node, basically. So, as I said, I have already deployed the contracts, and I have some nodes. We are going to do this topology. I have Satoshi, that will be like our light client. We have Sergio, Vitalik, and Andreas, that will be our full nodes. So right now, I only have a channel between Satoshi and Sergio, and I'm going to bootstrap this network. So for that, here I have PyCharm with the 4 nodes. The hub is running, Sergio, Vitalik, and Andreas. And since they are up and running, I have also the user interfaces of each node. So here I have the user interface for Sergio, for Vitalik, and Andreas. So I'm going to show you this interface because it's the interface of management of the Lumino node. Each Lumino node has its own user interface, and we have a dashboard that shows the payments that will receive it by this node, the payments sent, the failed payments, the payments that are in progress, and we have here a section that has the latest 5 payments that the node sent and received. Over here, we have the address of the node. Then we have the tokens section that shows all the registered tokens on Lumino. I have only the Lumino token, and I can see that this account, the Sergio account, has 75.4 Lumino tokens. Sorry. Then we have the channels. Here I have only one channel with the light client with Satoshi, and this section provides the possibility to create a new channel, to send tokens to a partner, to pay using this channel specifically, to add a new deposit, or to close the channel. So right now I have only this channel with no balance with Satoshi. And finally, we have the payment section. This payment section shows the historic payments, basically, all the payments that were sent or received by this node. So let's make the network. We need to create a channel between Sergio and Vitalik. and I'm going to put one token from Sergio to Vitalik, and then I will create another channel from Vitalik to Andreas, putting one token too. So after that, we can make a channel from Vitalik to Andreas, and we can also create a payment from Sergio to Andreas through Vitalik. So okay, this is Sergio, and this is Vitalik. I'm going to create a new channel. I need to put the partner address of Vitalik and the Lumino token contract address and the amount of tokens that I want to put. So these operations takes a while because it implies an chain operation and also 5 lots of confirmation. So it will take some seconds in order to succeed. So okay, here I have that the new channel was created with Vitalik. The deposit is already pending because I have 0 balance. And on the Vitalik side, I have the channel with Sergio. And after some seconds, the balance update is shown, and now I have 1 token from Sergio to Vitalik. I'm going to complete the network by adding a channel from Vitalik to Andreas. This will take some seconds too. So after that operation succeeds, we will have this topology, and we can start making the payments. So okay, the new channel is created between Vitalik and Andreas, but we still waiting for the deposit. You can see it on the Vitalik side and on Andreas side. Now that the balance is correct, we have the network ready. So now I'm going to make a payment from Vitalik to Andreas. Basically, I want to do this. I want to send from Vitalik 0.1 tokens to Andreas. So it will take 0.1 tokens from this side, decreasing to 0.9, and Andreas will be receiving the 0.1 tokens on the right side of the channel. Going to 0.1, and after some seconds, the payment will be successful. So right now, on this side, I have 0.9, and on the Andreas side, I have 0.1. Let's now make a mediated payment. So, sorry. Now I wanted to send from Sergio to Andreas 0.1 Lumino tokens, but Sergio doesn't have a direct channel to Andreas. So Lumino resolved this by creating 2 locked transfers. The first one from Sergio to Vitalik, and the second one from Vitalik to Andreas. And when this transfer is successful, this transfer can be successful later. So let's make the payment. Now I'm going to send from Sergio to Andreas. As you can see, the balance is decreasing here. And since the transfer is successful, Andreas has received a new 0.1 payment, and the balance between Vitalik and Andreas now is decreased too. So basically, that's pretty much this scenario. So, well, right now I'm going to show and talk a little bit about the light client. You can scan these two QRs. The first one is the light client SDK, and the second one is our example light client tab. This is just an example application, but it can be used like a playground or for test the Lumino light client. Both repos are on the RSK Smart Organization of GitHub, so you can go there and see the full code. So basically, the light client, as Alejandro says, is a JavaScript project, NPM package, that is pretend to be running on web applications or mobile applications using React Native. The main technologies that are used on the light client are the Redux Saga in order to handle the states of the SDK and handle the side effects. Then we have the Ether.js dependency in order to sign transactions and sign messages between the hub and the light client. And then we have integrated also the RNS domains in order to create channels using domains instead of addresses, and also making payments using RNS instead of an address. So let's see the repo. Here you have how to install the SDK. It's just adding the dependency of Lumino Light Client SDK. And on this README, you have all the documentation about the SDK. But I'm going to show you a complete example of how to integrate the SDK into a web application. So if you want to create a front end in, I don't know, React or Angular or something like that, and you want to start making some tests or just play around with Lumino, you can see, take a look at this full example snippet. This file is code, but it's also documentation about the steps that you need to complete in order to fully integrate Lumino Light Client SDK into your web application. So this is a suggested way of ordering the initializations of the different parts of the SDK. First of all, you need to initialize the SDK. Then you need to prepare the notifiers. That the notifiers are components that listen to the events on chain. They listen on the open channel event, the closed channel event, and notifies the users, the light clients, for when one of these events comes up on chain. So it's a way to, okay, we trust on the hub, but we also double check using notifiers. So this example uses 3 notifiers, but you can configure the quantity that you want. But you must know that when a light client makes an on-chain operation, it waits for at least the half of the notifiers to give a response. So it will be a good idea to have an odd quantity of notifiers. So we need the SDK, we prepare the notifiers, then we set the callbacks for when opening a channel and also from when we close a channel. The callbacks are basically code that triggers when something happens on the SDK. So if you want, for example, open a channel and after that show a toast or a modal, or maybe you reload the channels or invoke an external API or something, you want to do an action after the channel is opened, you need to define what will be the behavior of that callback. After that, you can open a channel, make a deposit, make a payment, and finally close the channel. So I will go step by step on the snippet. We first import Lumino, that is the main object of the SDK. The local storage handler, that is the storage handler that Ale mentioned, is basically, this is a default implementation that is using local storage, but if you work with React Native, for example, you can provide an async storage or something like that. And then the default signing handler. As Ale says, this can be provided externally. For example, we have integrated Lumino SDK with Nifty, a wallet that is a fork of MetaMask, and we didn't provide the signing handler. We use the signing handler from Nifty in order to be sure that the security of the SDK is not related with the SDK itself, is related with the security of Nifty. That is a wallet and has invested a lot of time in security. So we define the notifiers, URLs, the URL of the RSK endpoint. This example is using just localhost. The configuration params for the Lumino initialization, the chain ID, in this case the regtest one, the RSK endpoint, the hub endpoint. This is the URL of the hub that you are going to register with, the address of your light client, and the token network registry address. Then you have the initialization of Lumino. You need a Web3 instance. You need to initialize the signing handler and provide the init of the Lumino object, the signing handler, the local storage handler, and the configuration params. After that, you're ready to prepare the notifiers and prepare the callbacks. Basically, you can prepare the external things that you're going to use. So prepare notifiers. First, register the light client with each of the notifiers and hits the API of each notifier, saying, okay, I want to subscribe to any open channel that I'm going to do. So every time that I open a channel from the SDK, these three notifiers will be sending me notification about if the open channel contract event was successful emitted or not, because maybe the hub is corrupted or something like that, and it's telling me that, yeah, the channel is created, but the notifiers say that that even didn't happen on chain. We can also subscribe to a closing channel in a token network. So I can also receive a notification from the notifiers in order to know if I close a channel that happened on chain or not. And we can also subscribe for when a partner closes the channel. And this is important because when a channel is closed by a partner, we need to submit the balance proof from our side. So it's important to notice this from the light client side. And then we have the make payment. This basically receives this object that is the partner address, the token address, and the amount of tokens that we want to send. And internally, this action resolves all the protocol of Lumino. Basically, it signs the message on the light client side using the signing handler, and it sends it to the hub. And after some milliseconds, the hub has newer messages from the light client, so the light client get it. It signs again the response and send it to the hub. So after the messages of the protocol are complete, the payment is completed. And finally, we have the open channel and deposit on channel and close channel that are the three on-chain operations that currently the light client SDK supports right now. And that functions receives the parameters that must be sent to the smart contract and create a signed raw transaction, a signed RSK transaction on the light client side, and send it on chain. So basically, that's the on-chain part, and then we have the callbacks settings. You have a callback for any operation. You have a callback for when requesting an open channel. For example, I want to show a toast when an open channel is in progress. Then we have another one for when the channel is opened successfully. This is important because this is a good moment to reload the channels because we have a new channel on our application. And also, it's a good idea to subscribe to the events of the notifier in order to know when this channel is closed after we open it. Then we have a deposit channel callback for when the deposit is successful, a request close channel, the close channel when the close channel is successful, to receive a payment, send a payment, and complete a payment. So basically, we have a callback for each operation to trigger some action before the operation is successful, and when the operation is successful or failed. So this is a guide in order to integrate the SDK, and we have then we have the distributed app that is an example here. Basically, this application is built on React and only includes the SDK, and it integrates with 3 notifiers. And I'm going to show you how it looks. Basically, it's this application. You have an onboarding button that registers the Light client into the hub. You have the possibility to open channels and also to send tokens. And here I have the channel between Satoshi and Sergio. Let me show it. We have this situation between Satoshi and Sergio. And the hub is in charge of broadcasting the messages between Satoshi and Sergio in a payment. So I'm going to make a payment from Satoshi to Sergio. We have 0.3 from the Satoshi side, and we have 0 from the Sergio side. I'm going to pay 0.1. Here, a toast is displayed. This is the callback that we have set. And after some seconds, the payment should be successful. Here I receive 0.1 from on the Sergio side, and here a toast is displayed that the payment is successful. So these toasts are shown because we set the callbacks for when a payment is wanted to be sent to a partner, and we also set a callback for when the payment is completed. That's pretty much the Light client, and that's pretty much from our side. So we would like to hear some questions from the audience. So I don't know if somebody wants to ask any question. Nobody? Okay, so thank you everyone for the time, and we are looking forward to see you guys trying Lumino. And any question, you can send us an email or submit an issue into the GitHub. Thank you very much.
Well, thank you all. Thank you, Marco.
Thank you, Ale. And you can go to the developer network.
Exactly, that was what I'm going to say. Here on the chat box, I left you the link so you can visit there. And well, you know that there we have an open chat, open the 24 hours, so you can ask any questions over there. Okay, thanks, Rich. Thank you all. Thank you all for being there. Bye bye.
Bye, guys. Thank you. Bye-bye.